Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on graphing logarithmic functions. First example that we want to take a look at is y equals log of x in base 3. Now, what we want to try to do here is we want to make a table, an xy table, until we can maybe understand how logarithms, the functions actually look. Right now, make a table, and let's just plug in values. Now, what you want to do here is you want to be careful of what values you want to plug in for x. You want to plug in values that are going to be easiest for you. So again, thinking about this log of x in base 3 means 3 to what power gives you the x. So what that means is an exponent. 3 to what power gives you x. So what you want to do is you want to make these as simple as you can, all right? So let's try 1 in there for x. 3 to what power then gives you 1? Well, 3 to the 0 power is 1. So we have 3, 1, all right? Now, let's try to think of another number that would be easy. Let's try, how about 3 itself? 3 to what power gives you 3? 3 to the first power. So 1, 2, 3, 1. So there's another point. Let's try another one. I don't want to try like 6, because 3 to what power equals 6? I don't know that. But I could figure out 9. 3 to what power gives me 9? 3 to the second power. All right? So 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. All right? And maybe you can start to see, oh, this thing, as it goes to the right, it's going to kind of level off. It's going to gradually increase. But what happens as it gets closer to the x-axis, or to the y-axis, So let's go backwards. Let's go a negative number. Let's don't want to put in -1, because that might be a little bit more complicated. But how about let's put in 1/3. That's going backwards. 3 to what power gives you 1/3? 3 to the -1 power, right? So at 1/3, we're down here at -1. So right there. And another one would be easy to plug in, will be 1/9. 1/9 is really close to the y-axis here. And 3 to the -2 power. So it's right here. Now what's going to happen is we're never going to be able to have a negative x value, all right, a negative integer here for x, because 3 to what power gives you a negative number? That's not possible, right? So it's never going to cross this y-axis. Y-axis acts as what we call an asymptote. Never gets past that line. Gets closer and closer, approaches it, but never gets past it. All right, so here is a first example, y equals log of x in base 3. Let's take a look at another example. This example is very similar to the first one. This one's y equals log of x in base 4. So the only difference here is the base changed. All right, so again, let's make a table and see how this is going to affect this graph. Again, I want to choose numbers that are easy for me to plug in. So remember, think of exponents or logarithms as exponents. So it's 4 to some power equals x, right? So you want to plug in easy numbers. So let's go with a 1. 4 to the 0 power is 1. All right, so it's 0. So 1, 0. Get common point there, common point. Let's try 4. 4 to what power equals 4? 4 to the first. So 4, 1. So 1, 2, 3, 4, 1. Oh, this one is just going to start to go like this. The next one will be like 16, 2. And so it's just going to gradually increase compared to the previous one. And then we would try maybe a point like 1/4 for x, and it would be -1. So a little bit closer to the x-axis, and then 1/16, which is a little bit closer to the y-axis, but it never again goes past the y-axis, because that would be an asymptote. X can never be negative here. All right, so it didn't really change that much. It kind of looked the same. The bigger that base number gets, the more quickly it's going to start heading off to the right. All right, it's going to level off a little bit more quickly. The first time it was at 3-1, then this time it's 4-1, and then it was 9-2, and then it was 16-2. So it's just going to become almost like a slope of 0 the further you go out on x. It still gradually rises, but it's almost going to become level the farther out you get. Now let's take a look at a different one. This one we have y equals log of x in base 1/2. All right. The other two we had base of integers, positive integers. This time it's a little bit different, but again, we're still going to approach it the same way and make a little table here. All right. So I want numbers. Again, if you want to think of this as an exponent, it might be helpful. 1/2 to some power equals x. And again, it's generally easy to choose 1 because 1/2 to the 0 power. Anything to the 0 power is 1. So that one's pretty easy. And 1, 0 tends to be a theme, a point here. Let's try 1/2. 1/2 to what power is 1/2? 1/2 to the first. So 1/2, 1. Ooh, this time we're going up instead of down. So it's about right there. All right, let's try 1/4. 1/2 to what power gives me 1/4? 1/2 to the second power. So 1/4 up 2. All right, this time we're going up instead of down. Let's see how it goes as we go further to the right. Let's go the number 1. 1/2 to what power gives me 1? So I'm thinking this. 1/2 to what power gives me 1? Well, we already did this one. I'm sorry. It was in the 1, 0. Let's change that to 2. 1/2 to what power gives me 2? Well, 1/2 to the negative 1. Because if you think about it, 1/2 to the negative 1, remember negative exponents just means to flip numerator and denominator, all right? And 2 to the first is 2, all right? So here we get, when we go 2, we get negative 1. So 1, 2, negative 1. The next number we could probably choose is 4. 1/2 to what power gives me 4? 1/2 to the negative 2. So 1, 2, 3, 4, 1, 2. This one is going to be acting a little bit different than the previous problems because it's going down from left to right instead of up from left to right. All right? That's because the base is different. The base is less than 1. When the base is less than 1, we're going to have a graph that looks like this. All right? In the previous ones, we had something maybe look like this. All right? But because the base is less than 1, this one's actually going to be a decreasing function instead of an increasing function. All right, let's take a look at another example. Here we have log of x minus 1 in base 3. So this is now the base 3. That was our first problem that we did. But this time, instead of being x, it's x minus 1. But again, we're going to make a table, and we want to try to figure this out. Now, when that was, if I've let this x be 2, then 2 minus 1 is 1, and 3 to what power gives me 1? 0. So 2, 0 is a point. Now let's try another one. I want that to be 3, so in order for that in parentheses to be 3, x would have to be 4. Because 4 minus 1 is 3, and then 3 to what power gives me 3? To the first. So 1, 2, 3, 4, 1. And then I want that to be 9, so this would have to be 10. And 3 to the second power gives me 9. 10 minus 1 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And you can see this one's going to look almost identical to the one that we had at the first problem. The only difference is everything shifted to the right one. Everything shifted to the right one. So if I went down to continue going backwards, I want that to be 1/3. So in order for that to be 1/3, I need this to be 4/3. 4/3 minus 1, so that would be negative 1. All right. So 4/3 is 1 and 1/3, and then down 1. And so it's going to look like this. This one's going to approach that line. But we'll actually never get past this is the asymptote. Thanks for watching. God bless.